Okay, so I have a question here. It says, show that the equation kx squared, okay, this is kx squared plus 2k plus 1x plus 2k plus 1x plus k plus 1 equals 0 has real roots for all values of k. So, colleagues, this question is based on quadratic equations. Okay, basically, what this question is asking us to find is the discriminant. Now, the discriminant tells us the nature of the roots of the equation. Now, colleagues, when I say roots of the equation, it's just the x values. Okay, remember, with a quadratic equation, you're going to get two x values. So now this discriminant, even before you solve the quadratic equation, it will be able to tell you the nature of the roots, okay? Or the nature of the x values. When you hear roots, it's just the x values of the quadratic equation, okay? So a discriminant tells us the nature of the x values of a quadratic equation. Are we okay with that, colleagues? Before I move further, we start. Mr. Emmanuel, are we okay with that? Madam Sylvia, the discriminant tells us the nature of the x values of the quadratic equation. Okay, what I've wrote here. Okay, it tells you the nature of the x values, which are called the roots. Okay, it tells you if they are real or if they're imaginary. Okay, that's what the discriminant tells us. Any questions before I move further? Okay, so these are the rules that you must remember. If your discriminant is greater than 0, then you have real roots. Okay, basically real numbers 1, 2, 1.2, 2.3. Okay, those are the kind of real roots we're talking about. Okay, you get values, basically positive numbers. Okay, even sometimes negative numbers. Okay, if your discriminant is greater than 0, if your discriminant is less than 0, you have imaginary roots. Okay? For example, if the square root of negative 2. This is an imaginary number. Your calculator won't give it to you. Okay? Your calculator, you try to type in your calculator the square root of negative 2. You'll see it will give you error. All right? Then if your discriminant equals 0, then you have one repeated real root. Oops. So obviously, the question that's coming to your heads is, what's this for? Why do we need to know if our discriminant gives us real roots, imaginary roots? Well, colleagues, some equations or some business functions, some cost functions, some revenue functions, okay, other business functions, they might be in the form of a quadratic equation. Okay. Now, this discriminant is basically telling you the validity of your quadratic equation. Okay. If your discriminant is greater than 1 or equal to 0, you have a valid quadratic equation. But if your discriminant is less than 0, you don't even need to, you have to change that quadratic equation. Are we clear, colleagues? This is just all about the validity of our quadratic equations. That's what the discriminant is telling us. Yeah? The validity through our x values. If you've got real values, then your equation is valid. But if you have imaginary roots or imaginary numbers as your x values, then that's not a valid quadratic equation. Are we okay with that, colleagues? Okay, this is Mr. Emmanuel. I like how we're moving, Mr. Emmanuel. Nice, nice, nice. Okay. Let's see, Mr. Foster, you're quiet. Are we okay? Madam Betha, Madam Florence, Mr. Joshua. The discriminant is all up. It's just a okay, okay, okay. Yes. So your next question would be, where do we find this discriminant? Colleagues, if you remember the quadratic equation, okay, x equals negative b plus or minus the square root of b squared 4ac divided by 2a. I should believe I don't have this. Yes. In this quadratic formula, okay, this is the quadratic formula. Your discriminant is this one here, this square root here. Okay, that's where the discriminant is found. This is the formula you're going to use to get your discriminant. So whenever you're solving a quadratic equation and after you've solved the discriminant and you're still finding the square root, you've got a negative number, you stop. Okay, because you won't be able to, your answers are imaginary, so your answers won't be real basic. Okay, so you stop if you have a negative number. If you have a positive number, you continue and solve your quadratic equation. Okay, so this is where the discriminant is found, and this is the formula that we're going to apply here. Because one finds if there are real roots for the value of k. You want to see, does k have real roots basically? So this is the formula we're applying here. B squared minus 4ac. This is how we find our discriminant. Okay. Now, format of a quadratic equation. Okay. This is a grade 11 topic. Welcome back to grade 11, colleagues. We're in grade 11 now here. This is the format of a quadratic equation. Okay. So, as you can see for our discriminant formula, we need to get our b. B is basically the coefficient of x in a quadratic equation. Okay, colleagues? B, coefficient of x. Basically, the number in front of x. When you hear coefficient, it's just a number before a letter. Okay? So, B is the coefficient of x, the number before the x variable. So, in this case, our B is this 2k plus 1. Okay, because we have an x, 2k plus 1 x. So our b is this 2k plus 1. So you say b equals 2k plus 1. Before I move further, any questions? Mathematics, we have to move at a slow pace so that no one's left behind. Any questions, colleagues? Okay. Okay, I keep on switching. Let me just leave it at the screen then. Okay. Any questions, colleagues? 2. X to the power 2. So our a, which is the coefficient of x squared, in this case a, in this case is going to be this k here. This k comes before x squared. Okay, so you're going to say a equals k. Let me just put it properly so that we are seeing. Yeah, a equals k. C equals k plus 1. Okay, c is the number without a variable, the constant. So c equals k plus 1. Any questions before we move further? Excuse me. A, you have seen the format of the quadratic equation here? Have you, have you written it down? Yes, you've written it down. How do I prove that you've written it down? Yes, kindly pronounce it. Mm-hmm. No, no, no. I want to see. I've removed the screen so that I hear you pronounce it. Okay. Let me not give you a hard time, sir. Okay, this is the format: ax squared plus bx plus c equals 0. Okay. So this format you apply it to the equation given to you in the question. Okay. Yes. So in the question you can see that what comes before x squared is a k. So that is our a. Okay. Whatever comes before x squared, it will be your a. Okay. A is the coefficient of x squared. Here we can see what comes before x is this 2k plus 1. So that is our b. Okay. B, coefficient of x. All right, sir. Then C. C doesn't have any letter, and yes, C hasn't got any letter. So even here, this k plus 1 hasn't got any x attached to it. So that is our C. Okay, sir? Hope that's okay. Any, okay, wonderful. Anybody else? Yes. Yes. And whatever course you're doing, if you just see a letter with the power 2, just know it's a quadratic equation. No matter how it is brought, whatever format is brought, just know that okay, it's a quadratic equation. Okay. Yes. So we've got our A, B, and C. And colleagues, this is very important because there will be more questions where for quadratic equations. So it's very important you get this concept, okay, of how to get you A, B, and C. So after we've done that, we just come to our discriminant formula and substitute. Okay. So B, substitute with 2k plus 1 minus 4 times, we substitute A with k. And this C, we substitute it with k plus 1. Okay, colleagues, here what has happened is just a matter of substitutions. B is this, A is that, and C is that. So here, first things first, let's simplify this expression on our right hand side. Okay, 4 times k is 4k. I'm going to do it step by step. Okay, first multiply 4 times k. Although when answering this question, by the time you've reached here, you have to have expanded this one. But I just want to expand the one on the right hand side, then we expand this 2k plus 1 squared. So you're going to do 4k times k, 4k squared. 4k times 1, that is 4. Are we okay with that, colleagues? Okay, remember step by step. Next, distribute this negative sign. Colleagues, always remember in mathematics, if you have a negative and an expression with more than one term, distribute the negative sign. Okay? Don't just leave this as 4k squared plus 4. No. So this negative, it's like there's a negative 1 here. Negative times 4k squared, negative 4k squared. Yes? Mm. Yeah. Oh, thank you, sir. Thank you. Thanks for being observant. Sorry, I forgot about that. Yes. Thank you about that. Thank you, sir. Okay, so I distributed this negative sign. Negative times 4k, you get negative 4k. Always remember, colleagues, do this if you've got a negative sign and a bracket afterwards. Okay. Don't just go straight to simplify. No, distribute the negative sign. This 2k plus 1's 2k plus 1 squared, we need to expand it. Okay. 2k times 2k, 4k squared. Actually, we don't promote spoon feeding here. Colleagues, 2k times 2k, 4k squared. Okay, 2k times 1, 2k. Okay. 1 times 2k. Okay, we've already got that answer. It is 2k. 1 times 1, that is 1. Add the like terms. Remember, like terms, same letter, same power. So here, 2k to the power 1 and 2k to the power 1, these are like terms. So 2k plus 2k, 4k. Yes. So this expression, we put it here. 4k squared plus 4k plus 1 minus 4k squared minus 4k. Any questions? Yes, 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 yes. I was just doing it so that everyone gets what's happening. Okay. But this should be in your second row or third row. Yeah, basically your second row, basically. This is what I've written down here. Because you have to operate on everything. As you move to the next row, you're operating on everything at the same time. So, next thing, we need to put like terms together. Okay, so like terms here, 4k squared, and this negative 4k squared. So you say 4k squared minus 4k squared. The other like terms, 4k and this negative 4k here plus 1. 4k squared minus 4k squared, 0. 4k minus 4k, 0. So your discriminant is equals to 1. Mhm. 4k squared. Mhm. 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 No, no, no. This one here is not this one there. It's this one which we've got here when we expanded. Yes. Ish, let me even remove it because it can be dangerous to think like that. Please, 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 please. Yes. Uh-huh. Mm. Or it's this squared is coming for this is the one you're talking about, right? It's part of the formula for the discriminant. Discriminant is b squared. Yes, yes, yes. It's this step here. Let me take it here. After we expand, this is where I've put it here. Yes, yes, yes. Actually, I should have shown all of this in the workings here. I just wanted to I expanded on the side so that we just see, but in actuality, I should have put these workings there. But either way, you know what to do. You want to just say 2k squared, expand, and then you come to this. Yeah. All right. So our quadratic equation has got real roots basically because our determinant, no, discriminant, sorry, our discriminant is greater than zero. So we have real roots, real x values which are real numbers. Okay. So it is a valid quadratic equation, basic. The formula for the discriminant won't be given to you in the exams. I know someone was about to ask that. Yeah, the formula won't be given to you in the exams. So he just remember it. I don't know how you remember it. Yes. Can I give a practice question? So as the question says, show that the equation has real roots for values of k. One moment they just mention real roots, that's not okay. They're talking about the discriminant here. Okay. And remember, roots are just the x values. Okay, so let's do it as a class because individually some people are just going, they're not even going to try it. So colleagues, what is our a coefficient of x squared? What is our b coefficient of x? And what is our c, the constant, the, the term without an x value? Mhm. Yes, coefficient of x squared is k minus 1. So our a is k minus 1. What is our, okay? 2k. Wonderful. Mhm. Okay. Although c hasn't got a coefficient, it's just the constant. You just say the constant. Yeah. But thank you very much, sir. At least you've given us the correct answers. Thank you so very much. Colleagues, are we okay with this? Any questions? Does anyone remember the formula of the discriminant by heart? Just imagine you're in the exam room. This is the question you're doing. Can someone tell me the formula? Yes. Wonderful, sir. Wonderful. Is that Mr. Emmanuel? Okay. Okay. Yes. What do we do next? Mr. Emmanuel, just hold on, okay? I know you've understood. So, what do we do next, colleagues? Mr. Let's see. Who? Madam Florence, what do we do next? Yes. Yes. Okay, the hand raised. Okay, thank you, madam. That's correct. Yes. So this becomes k minus 1 squared minus 4. Our a is k minus 1. Oh, yes, 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 yes. No, it's good that you're paying attention. Sometimes, especially at 22 hours, I might slip up somewhere. So thank you very much for that. So yeah, 2k squared, and then 4k minus 1, k plus 1 here. Now here there are many ways you can do it. If you want to distribute, if you say 4 times k, 4 minus k, then you expand. If you want, you can expand these brackets, then distribute the 4. Right. So colleagues, which one are we comfortable with? Well, the 2k squared is by itself, so it's okay. Oh, just hold on. 2k. The question is here. We can either start by distributing this 4 through this k minus 1. After we do that, then we expand the brackets. Or the other way we can do it, we can expand these two brackets, then we'll distribute the 4. Either way, you're going to get the same answer. So let's try it, colleagues. Let's try it individually. Let's see what answers we get. Try this operation so that we compare what answers we get here. Okay. If you want to expand these two first, then distribute the 4, or distribute the 4 first to this k minus 1, then expand. It's network, colleagues. It's network. I know I was my band was finished. That's why I was kicked out now. Yes. So you are being laughed at, sure. That's unfair. Yes, the network is bad. So do not worry, the recording will be posted because I've seen it's very important that I put the recording for those without network. Okay, we are on this part here. We are expanding here. Can we expand, colleagues? We compare answers. Okay, I found my answer. Then this 2k squared here, 2k squared, the same as saying 2k times 2k. So you get 4k squared. Let me hear the answer here. Yeesh, colleagues. No one has found an answer yet? What other? Okay. Okay, when you expand this, before you give the final answer, when you expand this here, what did you get? Uh-huh. Continue, sir. Yeah, yeah, yeah. Who's that? Okay, just give me the final answer. The final answer after you simplify. Okay, that's correct. I'm just saying that's also correct. That's correct. I'm just saying when you expand this expression here, what did it simplify it to? For those who never got 4 as the discriminant. If you got your discriminant as 4, you are safe. That answer is correct. I will see you tomorrow. Okay. If you got your discriminant as 4, you're correct. But if you haven't got your discriminant as 4, listen in. Yes. When you expanded this, you got 4k squared minus 4. Was it minus 4? Yeah. Okay. Just hold on. Just hold on. Okay. Let me be illustrating what you're saying. Okay. Here. Okay. We go step by step there. For those who never got 4 as a discriminant. Okay, sir, continue. So when you start distributing, uh-huh, yes, yes, uh-huh, yes, yes. Mhm, okay. Kindly mute your mic, Sam. Whose mic is unmuted? Just mute it. Mm-hmm. Negative 4 times 1, 4. Yes. Mm-hmm. Then continue. Wait, before you collect, before that, just simplify this one in the bracket. Mm-hmm. Hold on. Okay, just hold on, sir. When you add 4k minus 4k, these two go. Yes. Then now you can continue where you are at. Hmm. Yes. Hmm. Yes. 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 Thank you, sir. So your discriminant is 4. So since it's greater than 1, what type of roots do we have? Hmm. I hope we're all okay with that.